Hi everyone, in this video I'm going to review prime factorization, greatest common factors, and least common multiples. The first thing we'll do is find the prime factorization of four numbers. I'm going to use the factor tree method. I divide 120 by 3. 3 is a nice prime and it's easy to start with. I can see that 120 is divisible by 3 if I remember this or use my divisibility test rules. 3 goes into 120 40 times, so I mark my branches 3 and 40. 3 is prime, so I circle it. 40 is not prime, so I don't circle it. I continue on, and I keep dividing. Here, when I divide 40, I can divide it into 2 times 20. Then 20 is 2 times 10, and then 10 is 2 times 5. Notice I've circled the prime end of my branches. I've collected this data up here and I've written it finally in order as 2 cubed times 3 times 5. That's the prime factorization for 120. Now let's look at 225. When I look at 225, I see that it's divisible by 5. 5 goes into 225 45 times. Then I divide 45, which is not prime. 3 goes into 45 15 times, and 15 is 3 times 5. There's lots of ways to do factor trees. For example, you might have written 45 as 9 times 5, and in which case you would have broken the 9 into 3 times 3. Altogether, the prime factorization of 225 is 3 squared times 5 squared. I used a factor tree before, and I can use it for 240, but I already know that 120 is 2 cubed times 3 times 5, and since 240 is simply 2 times 120, I can multiply in an additional factor of 2. Therefore, my prime factorization of 240 is 2 to the 4th times 3 times 5. Now I'm going to prime factor 196. 196 is divisible by 4. You might not see this immediately. Remember, you have to look at the last two digits. And I like to think of 96 as 80 plus 16, both of which are obviously divisible by 4 to me, and so therefore by divisibility rules, so is their sum. 4 goes into 196 49 times, then I break down 4 into 2 times 2 and 49 times into 7 times 7. So my prime factorization of 196 is 2 squared times 7 squared. I collect this data here. I'm going to need it in a few minutes. Now I'm going to determine the greatest common factors of some number pairs. Remember from our main reading that the greatest common factor of two or more numbers can be built by using each prime factor the minimum number of times it occurs. Let's see that in practice. Here's the prime factorization for 120 and 225. I'm using the lineup method. I write the prime factors of 120 and I write the prime factors of 225. I line up common factors and I leave gaps where there are no common factors. 225 does not have any 2's, so I leave a big gap here. 120 only has 1 3 and 225 has 2, so I leave a gap here. 225 has 2 5's, and so technically there's a gap here. Now I need to determine the greatest common factor. I mark the numbers that the two numbers 120 and 225 have in common. They both have 3 in common, they both have 5 in common, so that's the minimum number of times they occur in common. So that's 3 times 5. There's only 1 3 and 1 5 that they both share. You can look up here as well. When I look at these two to see that minimum concept. When I look at this, the minimum power on 3 is 1. The minimum power on 5 is 1. There is no 2, so you think of that as a 0 power on 2. So no 2, or just a factor of 1. So greatest common factor, 3 times 5. Now let's look at 120 and 225 in a different way. by just looking at the common factors list. I can make all the rectangles that I can with 120 tiles and then list out the factors of 120, not the prime factors, just the regular factors. Same way with 225. You see, this is kind of a lot of work. Then if I compare my two lists, the biggest number they share in common, the greatest common factor, is 15. The lineup method tends to be quicker and less prone to error. But I thought you should see it this way so that you could confirm that you understand the overall concept. Now let's look at the greatest common factor of 120 and 240. When I line them all up, I notice that 240 has this 2 and there's a gap above, keeping things lined up with gaps as needed. Then when I compare the things that they have in common, I get 120. That actually makes sense. 120 is a factor of 120. 120 is a factor of 240. You can't have a larger factor of 120, so that automatically makes 120 the greatest common factor of both 120 and 240. This is always the case. If you have a number A that's a factor of another number B, then the greatest common factor of those two numbers is A, the smaller number. Now let's look at 126 and 225. 196 has factors 2 squared and 7 squared, 225, 3 squared, and 5 squared. When I line these up, I see I have a lot of gaps. It almost appears that they have no common factors, but remember that 1 is a factor of every number. So I add in my 1 here just so that I can help see what's going on. There's no 2's in 225, there's no 3's or 5's in 196, and there's no 7's in 225. The only number they have in common is 1. We say that the two numbers 196 and 225 are relatively prime. When you have the greatest common factor of two numbers and it's 1, then those two numbers are relatively prime. That's the definition of relatively prime. Let's look at least common multiples. And remember from our main reading, the least common multiple of two or more numbers can be built by using the maximum number of prime factors in each of the numbers. Let's look at 120 and 225. We've already done most of this work, and we are just going to use our lineup method again. When I write out 120 and 225, now I mark each factor. I need all of these 2's, I need 3, here's another 3, here's a 5, and here's another 5. Notice the maximum number of 2's here is 3. I have my 3 2's. Notice the maximum number of 3's is 3. I have 2. I have 2 3's. Notice my maximum number of 5's is 2. I have 2 5's. I line up and I bring every number down. Not just the ones in common, but every single one. Now let's look at 120 and 240. I do the same thing. I line up, I bring every number down. Notice my maximum number of 2's is 4. I have 4 2's. My maximum number of 3's is 1. Maximum number of 5's is 1. And I line all those up and I get 240. And again, this makes sense. 240 is a multiple of 120 and 240. It's the smallest multiple of 240, and so it's the least common multiple. This is again always the case. If A is a factor of B, the least common multiple of A and B is B, the larger number. Now let's look at 196 and 225. When I line them up and mark the factors, notice that each one of them is marked. Remember, they don't have any common factors other than 1. So I have 2 2's that I need, I have 2 3's that I need, 2 5's that I need, and 2 7's that I need. Notice that this is actually the two numbers multiplied together, 196 times 225. This is always the case for relatively prime numbers. If the greatest common factor of two numbers is 1, then the least common multiple is the product of the original two numbers. You can think about adding fractions. If I wanted to add 2/3 plus 3/5, my least common denominator would be 3 times 5. There's a nice connection between greatest common factors and least common multiples, and that's stated in this relationship here, that if you take your two numbers and multiply them and divide by the greatest common factor, you'll get the least common multiple. That means that when the greatest common factor is 1, that would be 1 down here, the least common multiple is the product of the two numbers, which we just saw. You can also think of multiplying greatest common factor up to the left side here and see that that just means the product of two numbers is always the greatest common factor times the least common multiple. Let's check that relationship with our examples. We saw that the greatest common factor of 120 and 225 is 15, and the least common multiple is 2 cubed times 3 squared times 5 squared. When I multiply them out and compare them, I see that our relationship works. It's a little easier to see with the second example. The greatest common factor of 120 and 240 is 120. The least common multiple is 240. When I multiply those two numbers, 120 times 240, I get the same thing as when I multiply the greatest common factor and the least common multiple. For example 3, the greatest common factor of 196 and 225 is 1. The least common multiple is those two numbers multiplied. So when I multiply A and B, I get the same thing as when I multiply the greatest common factor times the least common multiple. I hope this helps you understand how to do prime factorization, greatest common factors, and least common multiples. I recommend the lineup method for greatest common factors and least common multiples. Once you get it, it's the easiest method.